2 years ago, Jesse Wilson did a talk about writing code that lasts forever. Some of you might think that he was talking about the Roman Empire, but he was talking about Cash App, actually. And today, I'm going to present how many things are organized within the application of Cash Android. We'll see some code. We'll talk about process, design. It's going to be a bird view of everything. And it doesn't mean that we think it's like the best or anything. And another famous developer from Cash App, Jake Wharton, is famously critical about Google APIs. Could be fragment, many things. And within the team, he always reminds us that it's not because something comes out of Google that it's perfect. We are all engineers, and maybe some are smarter than others, but it doesn't mean that everyone, some have the truth and some others don't. And so please keep that in mind when you see stuff that people at Cash App did. So this is a presentation of Cash App. It's really big in the US, but that's it. The basic feature is sending money to people. And it's not instant in the US, and that's why I guess it was a big market to fill. We cheat a bit. So for instance, we don't really care about config changes. It's always portrait mode. And if there is like a difference in night mode, language, or whatever, we just restart the app and don't really sweat about it. We don't support tablets, this kind of things. And so this keeps more or less what we do simple. And so on top of sending money to friends, you can have a card, you can have boost, so kind of cashback when you use it. You can do savings, you can get your paycheck on it, you can get your taxes filed, you can buy stocks, you can as well buy Bitcoin for those who like it. And so when I said big in the US, it's the first finance app on the free apps. So we have many people, 56 million active. We take a really small percentage on top of them, but that makes a lot of money. And that's big good for us. On Android, we have a bit more than 60 developers. We're getting a lot of modules now, and even more lines of Kotlin. It's getting exponential as you recruit people. But we'll see why it's not really a problem. And so we'll see first how we build a screen. So we don't think about navigation or CI or whatever. It's just how do we go from data coming from the network to the screen. And so we'll go one by one. So protobuf is kind of a protocol defined by Google, which defines APIs. And this is what you'll share between iOS, Android server, saying, OK, this is how the message would look like. This is how the service would look like. And they provide libraries to generate this code. It's really good as well for networking. Not like JSON, you need to send a string. This is going serializing everything efficiently. And even though Google provides the app to generate things, we Square build something called Wire. And so Wire is for managing your protobuf. We can generate Java, Kotlin, Swift, and a few more. We didn't like the APIs as well on what Google gave. And for instance, they introduced some types called duration. And if you look at this, duration would be message duration. There is like a field nano, a field seconds. And when you generate this with the Google type, you get like a Pojo second nanos. But when you code on Java or Kotlin, you want to use the Java time duration type. And this is what Wire will give you out of the box. And so we have this small optimization. And Wire is also built on top of Kotlin Poet, something else that we built in order to generate Kotlin classes from Wire. And so you'll see this pattern of things that we needed, and we just ended up publishing them. The network is using Retrofit. I'm hoping that everybody does it, which is built on top of OKCP, which is built on top of OKIO, all made within Square. And they are all really still active. On the database side, we have SQLite. I don't know if it's a rival or Room or anyway. It's been built for a while. You write your own SQL within SQL files. SQLite will generate code, now Kotlin code that you can use to communicate with your tables. It will take care of migrations and is rather cool. And it's built on top of SQLite. And I have a fun fact about this. So SQLite, you would think that the light is for small, like a small SQL, small database. But apparently the founder, come on, I forgot his name, Richard Hipp, I think. He just loves rock. And so when you name rock, there is a "ite" at the end, like Titanite. And so he doesn't say SQLite, he said SQLite, because he just loves rock. That's a fun fact. And SQLite also has this really nice icon, which nobody can't ignore. So we have the backend block, and so within this we have services, which is basically talking to the network, managers doing things. We have syncers, which do things as well, repository as well. So we'll see a few examples. One would be a service. So using Retrofit APIs, we define just an interface, and then Retrofit will inject for us the implementation. The interesting thing about this is that you see the return type. So we have the request and response. Those come from the protos, and they are generated by Wire, but they are wrapped as a result into what we call the API result, which is a way to wrap the response. So when you do HTTP, you have the response, and before reading the body, you need to know if it's successful or not. And in order to avoid for everybody to deal with it, we just wrap it into this small type, if it's a success or a network or HTTP failure, and then we let the caller deal with it. And it's wrapped in a sweet sealed class. You can just one statement it, and really fun to use. Another example of some backend type, and you'll see all of them are really reactive, for getters at least. And whatever the reactive way of doing it, it's going to be reactive. And we'll see why I say that. So we just have two methods returning a flow. We are going to have an interface that is going to be injected into the other upper layers or other types. We have a real implementation, which is just, so we'll see it again, but we use Dagger, so everything is injected. We do the test on the real investment entities, and then we write a fake that is going to be used. For instance, if these entities is used in a presenter, when we test the presenter, we won't be using the entities, we're going to be using the fake one. And coroutines, flow, and shared flow and stuff like this have made this testing really, the faking of it really easy. And so that's what we're doing. Another one that I really like is reactiveness through compose. And just annotate a method like returning one object by composable makes it reactive, and I really like it. And the implementation will be the same as in a view. You have a composable method, and so within it, you have all the APIs that you want. We can call the database, get a flow, map it into a state, return it, and so all the code you have in this is imperative. RX was a nightmare if you needed to do operation on top of other operation. It didn't really scale easily, especially simple things like for loops, if statements were a bit of a pain. Flow was a bit better, but I don't think it beats what we can do within those composables. And fake, super simple. We have a mutable state, so anybody, like any code could update investing states, and then anybody listening to the investing states method would get an update. The way, and we're going to see later how we can do this. So we have the MVW architecture, which is just a way to say that we don't really have like a way to do things. We keep principles in mind, which hopefully everybody follows now. So we have UDF, which is basically data goes one way only. It never goes back, and there is only one way to go. Single source of truth. So I don't know. Say you show a page that needs data from the network, and you have some cache. You won't be showing the response from the network. This will go into the database, and the only thing showing on the screen will be the database. This is a single source of truth. If you don't respect that, it's really easy to shoot yourself in the foot. Immutability, so you don't mutate things. And side effect isolation is, for instance, we'll see when you send an object from entities to presenter or from presenter to view or whatever, those are POJOs. They don't have state, they don't mutate, and they can't do side effects. And keeping that in mind, we had a healthy way of writing code, and we'll see as well through the APIs that we build how we kind of incentivize everybody to follow it. And so this is the graph that we had, and so we're going to look at the view and presenter relationship, and this is what we have. And the UDF is really this: data only goes one way. View model and view events are just POJOs. View events are usually just a sealed class of what can happen on the screen. It can be scrolling, a tap, I don't know, whatever. And the model is what is sufficient for the screen to create itself. We don't have substate, so basically when you need two view models to render a screen, that's not good, and so we avoid this. If you have one view model, you should be able to render any state of the screen. And so when we say view model, it's really just view model. It doesn't mean presenter, and there are no lifecycle or anything like this involved. I want to share a really nice pro tip that I came up with recently. So let's say you have two screens. There is like left view event, right view event, and there is a common widget that both share. And now you need to share the events. And the only way to do this right now would be to wrap it in both left and right. And so say you have a method handling left view events. You need to do kind of two when statements, one to unwrap the common event. But something that came out a while ago now are sealed classes. And what's really nice about sealed classes, interfaces, is so classes, sealed classes are like open class, so you can extend only one of them. Interfaces, you implement them, so you can implement as many as you want. So what you can do is adding the sealed interface on the common view event. And now if you do a when statement on left or right, everything is going to be aligned, because yes and no are now part of the left view event sealed interface. And take it home. So the presenter we saw, it was emitting a model, taking an event, and that's how its API is going to look like. The models are flow, reactive, and we have a send event method, which is to receive events. But we don't want the presenter to do its job, how to say this? We want to tell the presenter, okay, this is where you're going to work, this is when you're going to stop, and that's it. You don't want the presenter to start working out of the blue or anything. And by passing the scope object to it. This is how we decide it. And we wrap it in a binding. And as long as you don't call start on the presenter, you're not able to make it run. And this is the magic of it. But the API is a bit awkward to implement. And so I have it to do here because we've been moving from Rx and a bit of coroutine to composable presenters. And the big difference is, even though they are all reactive, observable flow, you return the stream, and you can wait on data to be emitted. Composable, you need like something right away. You need to return a value first. And this is why we still have some legacy presenters waiting to emit something. But once we get all molecule presenters, so emitting on subscription, we should be able to replace the flow with a state flow. So this is what we had in the past. We had an Rx presenter, which basically the observable transformer, taking an event, you map it, and you get a model. Coroutine presenter, which was not good. And then we came up with a molecule presenter using the same thing that we saw for the investing manager, using composable within its logic. So we got rid of the two at the top. We were able to migrate. And so this is the only thing that we have right now. And we have an example here. So in the model, you get the flow wave events. You just launch an effect, loop over them, and then you can do things. If you need to have effect on your model from the events, you can just have either you update a mutable state somewhere or do something. You can call all your flows, put them into a state like we did for the manager, and you return the model. Really easy to read. You don't get indent because you're doing some mapping, anything. Really simple. And the way to bridge it all, because you have a composable method, but you're somewhere where there is no, I don't even know how to call this, like you can't run composable method. Molecule is the bridge. Molecule is like, oh, you have a composable method, let me make a flow out of it. It has only two APIs, molecule flow, you pass a clock, and the composable body, which would be here the presenter, and it's going to make a flow out of it. The clock are basically to say, do you want the Android clock, which I don't think it's right actually, but I always think as, you know, on devices you have the frame rate. On every frame you get like a tick. This is what I think the context clock would match to. And the immediate is like, there is something to, like dirty data, we update. The other API, you give it a scope and you launch molecule into it. Those would look like this. Profile presenter, in both cases, is a composable method, and we get a flow or a state flow depending on the API that we use. So for the view, like the presenter, there is a model and an event that type it. We need to set the receiver so that the view can send events to somewhere, and the model. If you're not using Compose UI, this is what it would look like. You just need to override the two methods. For the receiver, you bind all the click listeners. So we don't even use, I forgot the name, like Rx, click listeners. I forgot the name of the API, whatever. Model you update one by one. And so you can set the view outside of it. And so it's really agreeable to do. But so we've moved away from this. And now, from Compose as well, we need a bridge, and we'll see why. Because like the entry point for views doesn't know about composable, and so we've been adding on top of the abstract compose view, which is coming from Android. We type it as we want. We made some magic happen, and now the consumer just needs to override the content method. Here, the require not null is the same as the to-do on the flow for the presenters. If you have streams, so flow, observable, emitting models, the first model you'll get will be null because it's a composable method, it needs something right away. If you have a composable presenter, you get a view right away, so you're able to require not null on it. And then just regular composable code. So what do we test? First, we don't test the DB. SQL Delight does it for us. We don't test the network, like Retrofit, OKHP, they're already tested. Protobuf as well. We only test from backend and above. And so you saw that all presenters, managers are reactive, which means that they basically have a flow. And Square, our Cash App, made a really nice library to test flows, which is called Turbine. And what it gives you, so we can see here there is discovery stocks method returning a flow of stocks or whatever. Turbine gives us the test method. And so within this scope, we are able to do a wait item, and it will be just sitting here with a timeout until some data comes up. Same, and at the end, we make sure that we consumed everything, because you don't want side effect to happen when you're not aware of it. And so we tend to make sure that all the tests at the end consumed every streamed. And so we came up with a pattern for this. We made a JUnit rule, which kind of wraps Turbine and just call at the end that, okay, do we have, is everything empty, no event, unconsumed? As for instance, we have a fake navigator. So when we go to somewhere, the screen is added to the stack. The color will be await next screen. And so again, it's using Turbine, it's going to wait a few seconds. And then if it timeouts, okay, nothing came out, and otherwise it will just continue to kick it. And we just add the rule. Fake navigator cannot be instantiated outside of it. People have to use the rule, and the call site will be like this. They get a navigator from the rule, and so in the test, you don't need to do at the end ensure that everything is consumed, and it's so easy to forget anyway, and it's just a nice pattern that we put in place. And so the test would be just like this. And so in both cases, it confirmed that the presenter didn't emit anything that we didn't catch, and same for the navigator. The manager test, will be the same, even though it was a composable method. And so now we do manager.test. So the same DPIs look like Turbine. And Turbine only tests flows, but we can use molecule here to do the bridge. And so you can see at the end, molecule flow of immediate. So every time there is a dirty data, you push. And then we do the test method from Turbine. So testing is really simple as well. For the UI testing, we use Paparazzi, which is a great library, and somewhat a bit controversy happens sometimes, but it's been great. This is a simple example. We defined a view, and so because we use the UI API, we set an event receiver, set a model, and then just take a snapshot of it, and it will generate file that you can either, depend on the task that you use, but you can either right away check what you have, iterate over it, and have do comparison like before after. And we'll see as well how we can create golden files so that you can detect when you made changes that you didn't expect to happen. The other thing really handy is, like, say you have a matrix of things to test, light, dark mode. I don't know, if you want to take accessibility with the font getting scaled to 2, this is something really easy to do as well. We defined 2 enum classes, one addressing the font scale, one addressing the design. And then we use the test parameter library from Google, which has been really nice as well. And so as test parameter, if it's an enum, it's going to run all tests for each enum constant. If you have a Boolean, it's going to do 1 for true, 1 for false. And so if we use them too, for the paparazzi, we can change the device config, use the font scale. The context, we can wrap the design. We have something that kind of wrap context and put some theme info into it. And this will generate, if I'm not wrong, 4 files. Anyway, 2 by 2. Here, there are no font scale, it's only dark and light, but this is what paparazzi would generate. And the workflow would be you write your test, you record them, and so this is the images don't end up into the build folder, they end up into a snapshot folder that you're going to be actually pushing to the repository, which are going to be the golden files. And on CI, you have the verified task, which is bound to the test task. It's going to generate the files on CI and compare them. And so if you have a big difference, it's going to throw. Sometimes, depending on the machine, because of metadata. So for instance, when we went from Intel to M1 or M3, even though for us human there was no difference in files, Paparazzi would complain there is like a 0.2% difference. This is something you can configure as well. But so say the test fails, you made a change. Paparazzi is going to tell you, okay, this image differs by 7%, and you can check the thumbnail to see how they differ. And you'll have this. I don't know what is the before-after, but anyway, you have two views. You can see the difference, and you can see them in POs as well. It's really handy. Otherwise, just to look at to make sure how it looks, you would have to open your device and do tests, or even Android tests. Because the really nice thing, and maybe its biggest strength, is that Paparazzi runs on the JVM, so you don't need to start an emulator to run those tests. Everything is on the JVM. And that's why it's actually rather complex, and the velocity of the project is not that high. So navigation, this is what when we saw with the go to somewhere. We have the screen key, which is just passwordable, so we can save the state. And this is the root for all screen. This is like a key, you pass it to whatever, and this means this screen, and it can have payload like this, like the stock details, we have the stock token. And when we pass it to the navigator saying, okay, go to stock details, the navigator is going to take care of finding the presenter, finding the view, making the magic happen. And this API is really simple. And so when we saw the presenter, when we loop through the events, like the close, is just a simple call as this. And so when we test, it's really navigator await next screen, expected what is it? Assert that is equal to some screen. And it's been really nice. And so the navigation, for it to happen, we need to provide three things: presenter factory, view factory, and transition factory. Because once there is a screen somewhere, we need to know which presenter is meant to be used, which view is meant to be used, and how are we to transition between the current view and the view to be coming soon. Now this is the bridge that we have for the presenters, because the presenter factory only takes the really simple presenter interface, but we have the molecule presenter, and we just wrap it so that the scope is used properly, so that the composable method dispose and these kind of things. And this bridging actually helped us. We had the same bridge for the reactive stream presenter, for the coroutine presenter, and we didn't have to change anything but our own presenter, because then there was as presenter transforming our molecule presenter to presenter, and it made migration really easy. Everything was really scoped down and really nice. This is an example of a view factory. There's a bit of code, but the nice thing is you can see that it can inflate from XML. It can take composable views, regular views. You could have conditions, feature flags, and you return the view. That's it. And so if you don't handle a view, you return null, and it's going to look into another view factory. Presenter, a bit simpler. We have our presenters. We have factories because they use assist inject, where we pass sometimes the screen or the navigator. And then we just wrap them as presenters. And when you do migration, that was the only line that was affected. And that also allows us to abstract away what we publish to the app. And so if you are in your own module, so for instance, we have an investing kind of modules, and it's only investing, and within investing, there is investing UI, presenters, backend, etc. And investing present factory, whatever we were doing in this would not affect anybody. And this is also really helpful. The navigator taking care of everything is called Broadway, and this one is not open source. I don't really know if it's going to be someday, but anyway, this provides those simple APIs that we like. And so this is it. You have a screen. We loop through all view factories. What's the view? What's the presenter? What's the transition? And the real navigator is like this, what I just said. And actually, the bind and attach and swap and stuff is the glue, and it's actually really complicated. And this is where, like, we use more or less the same thing that happened 10 years ago, I think. From the beginning, there was one activity, and this activity was like the container, but it was never one screen, one activity. It was we would just be building views and swapping those views. So we never get to use any libraries that Google provided for navigation or things like this. When we go somewhere, now we need to know what kind of screen is it. It is full overlay. We have some extra type. We need to take care of the backstack. This is also on us to take care of it. The old presenter, we gave it a scope. Now it's like scope, dispose, see you, bye-bye. We save the UI state, because that's what you do. So now we kick off the new presenter with the start. We get it, we give it its scope, and this is in this scope that you're going to work. We create the UI calling the view factory, so XML or not, it doesn't matter. If there are state to restore, we use it. Now we bind them together, which is, so we have the scope, and we just, it was the graph that we saw where the viewer presenter were exchanging events and models. Then we deliver the results if there are anything, when you do activity, create activity for result, these kind of things. Now we attach the UI, so like the view was created, but it wasn't really added to the main content. And if there is a transition, we run it. And then we get rid of the old UI. And I guess maybe that's the reason Broadway isn't open source. It's been a long effort to split what is first a container, what is a navigator, and making APIs that make sense for others as well has been difficult. But so this is all the glue that we are doing in-house. And anyway, I'm not looking after it, so I'm happy with the APIs. So now we get out of the screen, we have the app. We have two flavors and two types. And although we don't use the production debug, we have internal debug, internal release, production release. And so we get 3 APKs. And we call them dev, alpha, prod. Dev would be what you build from your machine. Alpha is going to be a Jenkins job running daily, once a day. Just from master, build some APK, sign it, and that's it. And prod would be what we release to customers every week. So I have a video to show the difference between the 3 and why it's been really amazing. So the green one is the app that people would get from the Play Store, regular customers. Cache Alpha is what employees would get, and so the one published daily. And one thing is that it's really easy to report bugs. So say they go into here and they see something wrong. They double tap, and they have, OK, report a bug. They can write what's wrong. You're able to assign, because we became so big for triage, we would pick up some names, so community Ryan. We submit, and it's going to create an email with a lot of metadata, all the payload that we need. It's going to automatically assign it to Ryan. And what's really nice as well, it attaches to this email a screenshot of the app, the database, preferences, view hierarchy, everything that we would want us as developer when we like, oh, there is a bug, tell me more. And this is it. We send the email. And it's been really nice within the company for people just to report because it's prod, so you can do it anywhere. And the cache dev is the monster because you'll see. The big difference is that there is a debug drawer, something that, so it does, you can report bugs as well. But the big thing is that you can pull from the edge some config menu. You can look through feature flags, so you can assign to your account from your device, okay, change my value from disabled to enabled. This will call the server saying, update this value. You have a tab with all the info about your device, the same thing that would be basically included into the email. And something, I don't know, many config. We can look at the DB. It wasn't actually working when I tried because I don't know why there was no tables, but it should work. It's like a really simple browser. And the best is you can change the endpoint. So now I'm hitting production. You can hit staging. You can hit a custom. So let's say you have a server dev with you. On their machine, they have something they want to try. You change the endpoint on your device, and boom, you're on it. You don't need to change the code, rerun, rebuild or whatever. From your phone, that's it. And then we have mock mode, which is the app without the network. We kind of wrote fake responses for most of the network calls, and meaning that you can use the device in plane mode, airplane mode, if you wanted to. The feature actually works. It's not just seeing, you can do write. So I forgot if I do it, but you can send money, you can do actions. And the other big advantage of this is that, say, you started to build a feature, server is not ready, you can fake the response and just try it already. And it's been really a blessing to work on this. Jake made a talk like, I don't know, 8 years ago, something like this, called U 2020, so maybe 6 years ago, no, 4 years ago, when he shows how it's done. And there are a few apps, like libraries that we use to do all this. One is Process Phoenix, so when you change the endpoint, we are going to kill the app and restart it. This is what Process Phoenix does. The double tap bug report is also published by Matt, and so anybody could use it. And then we use Dagger for do all the swapping between what happens on production, what happens internal release, debug release, and everything. And Dagger is built on top of Java Poet, which was built as well for just to generate Java things. And so, for instance, we have 3 applications and 4 components. Every time you see from the folder name based on the variant that you have. And this is where we do the differences. So alpha and debug, you add the double tap, debug, you add the debug drawer. And this has been really nice as well to, we are able to ship features to us without customers to ever see it, even by accident. And the way we do it is so we have the activity, we have the container navigator, whatever, and the content, which is the first graph that we saw with the view to the protobuf. On the debug build, we just take a debug drawer, and then we have now 2 views, and that's it. We just injected a view, and that's what it does. But just having, you have it with you, you don't need to rebuild all stuff, was really a blessing. We have workers, so code that need to run either when the app starts or when the activity starts. Simple API, you implement something, you register your worker somewhere, and it's going to run. It's been good as well. So we all usually push to the main branch. We don't have feature branch. And if we need to, like if something is not ready, we're going to hide it behind a feature flag. And so the feature flag is basically some remote value that you get from the network saying yes or no, or you have other values. And feature flag to false, it's not ready. Okay, now we think it's be ready. We can change the flag to, okay, you can show it to employees. Or we can do rollout, 1%. We look at the logs, no bugs, 5%, these kind of things. And so everything to master all the time. We have small and stacked PRs. And to master again. For PR reviews, we do, so trust by default is, I like to think, when you do some comments. If the PR was merged, would you do yourself the change, going to the code base and stuff like this? If no, then you don't comment. No need comment, just what's important. And then you approve. Unless it's going to be like a really bad thing, you just leave your comment, approve, and the person, you trust the person to actually read your comment and take them into account and merge. And so they can merge anytime they want, especially now that we get spread it out. You don't want to wait for the people to wake up the next day to be able to merge your thing. You don't want bike shading, so it would be like how to format the code. I don't have other examples right now, but everything should be automated. And so we have Spotless for this, making the format code. We have lint to prevent people from using APIs that we think and we, as a team, we consider obsolete. And so there are no human discussion. It's not, hey, don't use that, and then the other, feelings are hurt. No, lint says no, get away from it. And so version bump or renovate, just doing things for us. An example of a PR that I made, Kai, wrote a comment and he approved right away, and that was cool. There is another thing that we get on our PRs, which is 3 things. We get the differences before, after the PR on the APK size, method counts, the dependency graph, these kind of things. This from libraries that Jake made a while ago. On CI, we have Kochiko, it means like building or construct. And this is where we have all the jobs running. It was built in-house. I'm not sure why, but anyway. The only thing that I thought was interesting is we noticed at what point the task taking the most time was lint, and it was like 15 minutes or something. And we just splitted it up. We have like a small piece of code in the Gradle build saying, take, I don't know, the first 10, and you have lint debug shard A, then another shard. Because we can have a lot of shards, but we don't want to wait 50 minutes on one. Android tests, so we have really just, I think, 4 or 5 Android tests, so the one actually running on the device. We use Firebase for this. And the only thing that I see value in this is when you have stuff using reflection, injected into the app. So for instance, if you have Moshi, some generator or reflection injected, or what? I don't know if there are anything else, but that's it. Sometimes it crashes and you forgot to do something, or maybe with the as well for the ProGuard, if something has been trashed, these kind of things. We automatically release main branches all the time. And so we have release branches and master, so master all the time. And for every commit, it's published. So anybody could go on this website, download the APK, install it easily. And again, a bit like it's really easy to give feedback. It's really easy for people to test the app. And this is really important to incentivize all that. The design system. So we have some things not out yet, but anyway, we have our own repo. We have an artifact for all platforms, which has been really nice. So we have web, iOS, and Android. And it provides us with the colors, icons, dimensions, typography. And the best thing is that there is a website to look it up. We all use Figma. And the designers, when they set design on Figma, they use the same name that we have in our design system. So as developer, you look at the Figma and you already know what colors, things to use. And we had tools to migrate that made always a blessing. I'm almost done. Yep. So we have this is an example of the website. Icons, tokens. Tokens are the colors. And so the icons would be something like this. I looked for add, and I was able to see everything that more or less matched it. The moon, if you press it, you get the dark mode of it. I thought that was nice. Same for the colors. I look for button. Anyway, dark mode as well. And in the code, it looked like this. For the style, the theme is bringing me the style. I don't have to, do anything. Typography body. For the colors, we have semantic names. We have component names, base names. And this been really helpful when you want to build a view fast. And so we do functional teams. As I said, we have the investing, submodules, view, presenters, and everything. And the team is the same. We have investing team, payments team, cards team, and in each team there is like a PM, a design, server, mobile, QA, whatever. And it's usually bottom-up, meaning within your team, as long as you don't mess up others' work, you're free to do whatever you want. And it actually exploded because it kind of became messy, and sometimes we'd get a call from the top saying, okay, we need to stop this because it is a mess. Like we had a team building another service container, although we already had one, and anyway. The pros is really easy to go fast because you don't really care about the others. The cons is you can get conflict really easily. Like we had investing build a feature to send Bitcoin from USD. The Bitcoin team built a feature to send Bitcoin from Bitcoin. And like the customers were like, what's the, anyway. So you need communication. Anyway, and so the future, we are trying to remotely write code that's going to be sent, wrapped as JavaScript to the device. The device is going to download the JavaScript, install it, run it. And it's actually in prod already. So it's been a long time, but anyway. And as you see, open source is a big part of it. The key is also to open source what we use on our tech stack, because otherwise nobody is going to maintain it, and everybody is going to be angry at it. And everybody is entitled to do it, so good stuff. And I thank you very much for today. I will not take questions, but I'm happy to discuss it.